of OLS in the morning, that will affect the efficiency, biasness. Okay, it will affect the blue property, best linear and unbiased estimator property of the OLS model. Okay, so autocorrelation, there should not be any autocorrelation problem, number one. Number two, okay, after seeing R square, after seeing DW statistics, go to the sign, okay, whether it's a positive sign or negative sign. Then come to the testing of hypothesis, whether we are going to accept the null or reject the null. Okay, so you have to check the test statistics. Okay, test statistics. So as I said in the morning, it is t-test. Okay, so it is used to evaluate the significance of individual coefficient. Okay, the purpose of t-test was many. The purpose of f-test was many. So TSA, time series analysis. In this contest, time series analysis contest, the t-test is used to assess the significance of individual coefficient. Clear? So these are all we have discussed in the morning. Even in fact, I touched upon, okay, after taking a call, whether you're going to reject the null or accept the null, after taking a call, you're going to write the interpretation. Okay, whether it is statistically significance at 5% level, or 1% level, or 10% level. And we are all discussed these in the morning. In fact, I touched upon multicollinearity. There should not be any multicollinearity. Multicollinearity. That means there should not be any relationship among the explanatory variable, okay, the right hand side variable. If there is a relationship between the right hand side variable, what will happen? So we can't estimate the individual impact of x on y. Okay, because when the right hand side variables are highly correlated, it has high explanatory power. Okay, because one influences the another. So what will happen? The standard error will increase. The standard deviation I'm talking about, the standard deviation of a statistic. Okay, the standard error will increase when the two variables, say for example, demand. Demand is a function of price. Okay, simple example. Demand is a function of price. The quantity demanded depends on the price. Not only the price, now I'm going to incorporate income of the consumer. Okay, and that is also another variable. When income increases, that is also influencing the quantity demanded for the product. Correct? So when the income and price are correlated, just assume both are correlated. So what will happen? Their standard error will increase. We should be very careful. When the standard error increases, what will happen? It leads to acceptance of null hypothesis. Please, I want to tell you this one. Okay, there is a graph which is, I can plot the graph in terms of anomaly distribution curve. Okay, so the rejection, the rejection region become very smaller. Okay, acceptance of hypothesis region will become more when there is an increase in standard error. These are consequences.
Sir, again repeat.
Hello, sir.
Increase.
Yeah. Consequences of multicollinearity leads to high standard error. Please make a note, sir. Consequences of multicollinearity. Okay, when there is a multicollinearity which leads to increase in standard error. Okay. Okay, if you want more precisely, okay, I'll show you more precisely. If you want, okay, just a minute. Okay, there is a formula for. I'll share you just one small word file and I explain. Okay, this is a very dangerous consequences. Okay, serious consequences. Okay, so please make a note of it. See, multicollinearity. Okay. I don't want to take much time on it, just a simple explanation. Okay, multicollinearity. Okay, the problem. This is again after we discuss about this autocorrelation. This is multicollinearity.
We could not see over the screen.
Okay, sir. 1 minute, sir. 1 minute. I'll share, sir. I'll share. Share screen. Okay, we are discussing about the multicollinearity problem. Okay. So what is why this problem is considered? This is we call it as a gift of God. So this is attached with the data set. We can't.
Sir, you have to close the navigation.
Okay, sir. Just I type one word, sir. That's it. Fine, sir. Okay, multicollinearity. Okay, this multicollinearity is a serious problem. When it is a serious problem, this occurs under multiple regression model. When there is more than one independent variable, multiple regression model. Okay. Now, what is the consequences? So, if the both independent variables are correlated, what is the consequences? I will tell you. You know the formula. We are assessing the significance based on t-test, correct? Yes or no? Participants, answer to my question. How to assess the statistical significance of the individual coefficient? Through?
Using t-test, sir.
Okay, through t-test. You know there is a formula for a t-test. Okay, so coefficient. Please make a note. Coefficient of beta divided by
Standard error.
beautiful. Standard error of beta. Okay, now what will happen?
If standard error will
Yeah,
be higher,
yeah.
coefficient of beta will be less.
Yeah, now what will happen? You can see the numerator is the coefficient of beta, and you can see the denominator standard error of beta. We try to know reduce the variation in the data. We have to maintain minimum variation. That is we are all frequently telling the variation. No, whatever the data you are collecting, we should have a minimum variation. Okay, that is a problem actually. Okay, we should have a minimum variation. Okay, so if you have more variation, this is the sequences. That is what we are normalizing the data. So everything is connected in the time series. Okay, fine. Come to the point here. T-test, which is nothing but the formula for the t-test is the coefficient of beta divided by standard error of beta. Now I told you this the right hand side variable. Let's say y is a function of x1 and x2. Okay, let me write here. Y is a function of x1 comma x2. Okay, I want to tell you this one. When x1 and x2 are correlated, what will happen? This leads to the increase in the standard error of beta. You can take either x1 or x2. Okay, it may lead to increase in either x1 or x2. Okay, the standard error of x1 or x2. So what will happen when the increase in the standard error, the curve, no, you can see the level of that. What is that? The normal distribution curve become flatter and flatter. Okay, flatter and flatter. Okay, so which will leads to acceptance of. Please make a note. Acceptance of. What will happen when the low t value? When the standard error increases, what will happen? You just see the formula and tell me. T-test. When the standard error increases, what will happen? I'm marking here.
T-test will decrease.
Okay, participants, come on, tell me the answer. I don't want one or two a reply. Please come on. When the standard error increases, what will happen for the t value? The denominator increases. What happened to the t value?
The t value will increase, sir.
Increase or decrease?
Decrease.
So decrease, sir. Decrease. Fall.
So yeah, if you're not replying, it's very difficult for me to proceed. That's my problem, right? Okay. Low t-test, which is equal to acceptance of null hypothesis. You know, right? Null hypothesis. Null hypothesis. Okay. That's it. So that means insignificant t values. Low t-test is nothing but insignificant t values, t ratios or t values. That's it. Okay. So this is a very serious problem. Multicollinearity. At least I can have a solution for the autocorrelation. Okay. So here multicollinearity is again a serious problem. So what are the solution for the multicollinearity? You can drop one variable. Either x1 you can drop or x2 you can drop, or try to incorporate some other variable. Maybe I am just typing here x3, or transformation, first difference technique. Okay, just several trial and method. Okay, so This is about the multicollinearity. So you should be very careful, you know, before running a regression analysis, you should be taken care of the assumptions. No autocorrelation, no multicollinearity. Then only the model is a good model, provided the R square should be close to 1. Okay, if it is 66 or 67, 70, fine. Even above 60 is fine. Okay, we can accept. Depends upon the individual researcher's perspective, how they're looking at the regression model. That's very important. Okay, this is about the wireless model. Okay, now come to the next one. ARIMA model. Please make a note, ARIMA model. So ARIMA model is basic. ARIMA is nothing but auto regressive AR model. Okay, AR. First, let me come to ARIMA model. Okay, just make a note. ARIMA model. Okay. Let me bold this one. ARIMA model. What is AR term? Here there are 2 components, 3 components you have to. One is AR component, AR term. The next one is MA term. The another component is in between AR and MA. There is I. I is nothing but integrated. Is nothing but integration or stationarity condition. Please make a note. Stationarity condition. Okay. So I am teaching ARIMA model. Okay, please make a note. I am teaching ARIMA model. So ARIMA model consists of AR term, MA term, I. There is one more component called I in between AR and MA. That is integration or integrated. Okay, that is nothing but that represent stationarity condition. Okay, what is AR term? AR term is nothing but YT.
Auto-regressive.
Yeah, auto regressive. Sorry, I will expand that. Okay, so auto regressive term, that is AR term. Okay, is nothing but YT is a function of YT minus 1. YT minus 1. That's it, plus UT. Okay, you are always know add UT. Okay, so understood. This is the AR term. That means ARIMA was introduced basically for the forecasting exercise. Okay, forecasting purpose only ARIMA has been used. How many of you from finance here? Can you please tell me how many of you from finance here? Anybody from finance team?
I am from finance, sir.
Kamal sir.
Yes.
Okay, can you explain about EMH?
Efficient market theory.
Efficient market theory or efficient market hypothesis? Can you explain?
I mean, where all successive happening or occurrence should have something in common.
Okay, very closer. Okay, this is related to anybody? Anyone? EMH, efficient market hypothesis. Okay.
Actually, efficient market hypothesis. The previous or the historical price will not useful for predicting the future price.
Beautiful. Shiva sir, beautiful. See, there is nothing motivation behind, at least OLS. No, OLS. I have discussed about the theory. You know what theory in the morning we discussed behind the OLS? I have one. Sir, what theory we have discussed in the morning behind OLS model? What theory? Consumption theory. Very good. Please reply, participants. Okay, consumption theory. That means consumption is a function of income. When you are framing the regression model, it is based on the completely theoretical background. But for applying ARIMA model, nothing, no theoretical background is required, because it's completely ARIMA is introduced for forecasting exercise. That means the time series data, the nature of the time series data speaks itself. The data speaks itself. That's a slogan, we can say. The data, no, we have, right, share price. The data speaks on its own. So those were from the EMH. I will tell you there is the beautiful theory in finance, weak form efficiency theory, or random walk model. Okay, it's nothing but you can't use the historical price to beat the market, to predict the market. You understood? Now, of course, our Indian market is predictable. Our Indian market is predictable. Okay, our Indian market is predictable. So that is inefficient market. Sometimes the developed markets cannot be predictable. Understood? No. So why I'm suggesting, why I'm telling, if you are get a chance to test this, use this weak form efficient model, and this is highly helpful. This ARIMA is highly helpful for them. Okay, for the first you have to decide whether the market is forecastable or not. Okay, then it will be highly, you can learn about this particular model, ARIMA model. First, we have to find out whether it is predictable or not. Okay, come to the point. And we'll discuss in general. Okay, so auto-regressive term, that means the YT, the today's price is influenced by the past lag values, the past prices, it's lag values. Okay, this is auto-regressive term, auto-regressive. Okay, we are regressing using its own value. Okay, auto-regressive. YT is the function of YT minus 1. Understood? So now this is known as, please make a note, this is known as AR1. This is not, it's very difficult. This is not, no, easiest model. Please, AR1. Don't take it very lightly, but this is a beautiful model. Okay, very powerful model. Okay, fine. This is AR1. What is 1? 1 is nothing but the lag length. The lag length of, can anyone tell me what is the lag length of?
Some is with previous data. One
Yeah, the
year
lag length.
of previous data means previous year, 1 year back.
Yeah, correct, madam. That is T minus 1. What is YT minus 1? YT minus 1. YT minus 1 is nothing but previous days. That means previous past values of the dependent variable. Okay. We have to attach is not only the previous value or lag value of, please, lag. 1 stands for, normally it is mentioned by P. What is P here? P is nothing but the order, lag length order, lag length, please, lag length order. P stands for lag length. This is for your information. Okay, the lag length, sorry, lag length of order. Okay, order of what? Lag length of order, lag order of lag length, lag order of, you can put lag length or lag order, lag length, lag order of a dependent variable. Dependent variable. Okay, so YT minus 1. This is YT minus, so data speaks itself. This is a time series data. Okay, now this is AR term. Okay, this is, first understand this concept, then we'll go to the estimation. P stands for lag order of dependent variable. Okay, or I can write this directly. It is, can you tell me what is P here? In the above equation, what is the value of P? What is the value of P in the above equation?
1.
One. Don't hesitate. No problem. Unmute and speak. Okay. Give me the answer. Okay. MA. What is MA? MA is nothing but the same concept.
Moving average.
Yeah, moving average. So I'm going to use the same equation. This is MA term. But here instead of YT, I'm going to use UT. Okay. This I'm going to give as VT. Or you can put UT also, no problem. Okay, VT, why? Okay, VT means that's a normal error term. Now, why it is UT minus 1? Because it is not only today's, since YT is influenced by YT minus 1, the UT also influenced by UT minus 1. So this is MA, this is Q, sorry, Q. Why it is Q? Same thing. The lag order, again the lag order of the not dependent variable is a U. Basically this is U, okay, lag order of this moving average term. Okay, so I am putting it in the same equation. If you put in the same equation, you can see. Yes, sir.
What is a VT, sir?
Okay, sir. If it is confused, I'll put UT. Not a problem. Now you understand, sir, this error term. Okay, sir. You got it. No, this is normal error term, sir.
Sir, please repeat MA term. Actually, there's some disturbance. That's why I can't get it.
MR term is nothing but since YT is influenced by YT minus 1, so UT also, this UT is also influenced by UT minus 1. So this talks about which problem?
Autocorrelation problem.
Beautiful. What's your name? Agnesh. Agnesh, correct?
Anikesh, sir.
Anikesh, sir, super, sir. I need, yeah, participant listen. This is what I'm expecting. Since YT is influenced by YT minus 1, UT should influence by UT minus 1. So there is an autocorrelation problem. So I have to capture that. I have to use that problem. So see, UT here, listen, this UT is, what is UT? Unknown component. It can be shock. It can be anything that influencing the share price. Correct. So since see the equation, YT is influenced by YT minus 1, UT is also influenced by UT minus 1. So that concept, on that logic, I am going to use MA term. What is MA term? YT is also influenced by UT minus 1. Okay, already UT is there. Okay, UT minus 1. This concept I'm talking about. So YT is now just now I'm going to combine these, then you can able to follow. Please listen. I'm going to write this equation. Now you can able to follow. YT is a function of YT minus 1 plus, tell me, plus means another equation, what is another term? UT minus 1. UT minus 1 is the moving average term. Okay, plus normal UT. So this is AR1, this is MA1. AR1, this is moving average 1. Moving average is nothing but your lagged error term is nothing but the moving average. So normal UT I am introducing. Okay, I converted as a VT, but still okay, no problem. For
Sir,
understanding, this is UT.
moving average, just like endogeneity problem.
We don't have any endogeneity problem because we are using their lag value, that's it. Nothing called endogeneity here because it's not acting as a dependent variable. No?
Okay.
It's purely exogenous. See right hand side, that's it.
YT is exogenous only.
Exogenous only, yes. I'm not talking about endogenous now. Endogenous can be known because it's only one independent variable. Sorry, one dependent variable. So this is YT is a function of YT minus 1. This is AR1. The red color, no, I will shade it. This is AR1 and this is MA1. Okay, I'll put in some other color. This is MA1. What is YT minus 1? Anyone? What is YT minus 1? What is, no, what is YT minus 1? Very simple.
So this is the previous value of dependent variable, sir.
That means, sir, can I say like this, a past value?
Yeah.
Past
Past value of dependent variable.
Values are dependent variable. Auto regress. Yeah, auto regress. Beautiful. What is UT minus 1?
UT minus 1.
This is the error value, past value of error term, sir.
Yeah, past values of error term. Here, the error term is referred to as shock.
Yes.
Because in the stock market, have you heard about persistency effect? Because yesterday something happened in the stock market, it will be carried out for the long time. Have you seen this? Have you heard this? Yesterday there were some bad news that will be prolonged in the market for next 10 days, 5 days. Have you seen that? Have you heard this?
Yes, sir.
Yeah, the stock market, I'm talking about the stock market because this forecasting exercise will be maximum done on stock market. So stock market, if there is any news dissemination, information dissemination, whether it's a good news or bad news, that will reflect for a long time, which is called as persistency effect. This is a concept in finance. Okay, so since YT is influenced by YT minus 1, UT also influenced by the UT minus 1. Just assume this UT is nothing but the shock component, unknown component, can be shock. That's it. Okay, so this is known as ARMA. This is ARMA model. Yes, sir. Yes, sir.
UT1 is called as a shock.
Yeah, unknown component we can consider as a shock. Okay, because we could not quantify it. No. See, today's price is influenced by past price, but we are not capturing that shock, right? Then ultimately it will be taken care of by the error term, right? Got it, sir?
Yes, sir.
Yeah, that is a part of, sir. Your shocks are part of the error component, sir. So unknown component, it can be a news, it can be bad news, it can be a negative news or good news.
Yes,
That is what shock. So we can't capture it. So since YT is influenced by YT minus 1, we are assuming the UT also influenced by UT minus 1. There is no theoretical logic behind it because the data is a dynamic, it's a time series. So which carried over for just one point to another point, it's a dynamic. So it speaks itself. That's the logic behind it. Okay. So with the in the context of stock market, you can take it as a news, a shock, anything else, unknown component. There are many, okay, we can call it the unknown component shock. You can take as a shock, not a problem. Okay, so now this is known as AR component. This is known as MA component. AR1, MA1. This is ARMA model. Where this I comes?
Sir, one doubt. Here the YT is equal to function of YT minus 1 means this is not a efficient hypothesis. Am I correct?
No, sir. That hypothesis, I'll come back later because I'm not talking of, I'm not connecting here with
the past, no, the current price is equal to past price.
Correct, sir. If it is that, I'll come. If suppose, okay, I'll give the answer. Okay. If this YT minus 1 is significant, then the market is inefficient. Understood, sir?
Correct.
Yeah. This is the answer. Okay. Now, apart from this YT minus 1, we have one more component also. That is, one gentleman said, no, autocorrelation. We should have autocorrelation problem for ARIMA. So, autocorrelation must. Autocorrelation must. Please make a note. Make this point. Autocorrelation must. Why it is must? Already you know that this is must, no, because this is white. Since YT is influenced by YT minus, obviously there is a successive relationship between the two successive error terms, no? So autocorrelation problem occur. Okay, this autocorrelation problem occur due to shocks. Okay, ARIMA model autocorrelation problem exists. That is what people are trying to find out the lag order through spike. But here we are not using that spike method. It's a very old method. We'll see what can be done to understand our easiest way to do it. Okay, forecasting. Parsimony, something we call it a parsimonious model. Parsimonious model, exact lag length. See here what I mentioned. YT is a function of YT minus 1 and UT minus 1. What is the lag order? What is the lag order of P?
1.
Okay. What is the lag order of Q?
It is also 1.
Also 1. But is it? Can I proceed with this lag order?
Yes.
I should not. No, I should not proceed with the lag order. I have to identify appropriate lag order. Please make a note. I should. Please, this is a very, very important point, which is called as parsimonious model. I don't know exactly parsimonious spelling. Let me check. Parsimonious model. Yeah, correct. Parsimonious model. That means exact lag length, exact lag of P and Q. Please make a note. This is very, very, very important. This is very, very important. So what is my job now? I have to identify I. Understood? No. I have to identify I. Then I have to find out parsimonies, exact P and Q. Okay, so I have to find out two jobs left out. I have to, I just mark it here. One is I have to find out I. The second one, I have to find out exact exact lags of P and Q, so that it is the parsimonious fittest model or parsimonious model, right model. Okay, fine. So now what we are going to do for P and Q. So there is a procedure for Box-Jenkins methodology. There is a procedure for ARIMA model which is known as Box-Jenkins. Please, Box-Jenkins model. Okay. So Box-Jenkins methodology or procedure method. Box-Jenkins methods, or it is known as ARIMA process. For ARIMA process, this is also known as ARIMA model only. ARIMA process. That's it. ARIMA process. It's a very, a very difficult model actually. It's not the easiest one. We have to identify exact P and exact Q. That become laborious, tedious work. Okay. So now I'm going to show you how it will work. So I am going to take one series. Okay, I'm going to take one series. Let me open the file. So I have taken one series here. I'll just share the screen. 1 minute.
So can we apply ARIMA model on GDP prediction?
Yeah, you can apply for any, but provided there should be autocorrelation problem, madam. Okay. That you should have this MA term should be significant, otherwise not valid. Okay, fine. That's a basic condition. I'll show you in the process. You come to know. You can learn actually. See, this is the. Can you able to see the? Okay, 1 minute. Can you able to see the screen now? Can you able to see the screen?
Yes.
Okay. Yes, now, this is gold price. I have taken. Okay, just roughly. This is a gold price, and this is returns. Okay, this is returns. Returns, is nothing but the first difference. Okay, returns data. Okay, so now I am going to use the, let me see both the series. We'll see that.
Return means stock return or market return?
Anything, formula remains same, sir. You want to calculate, I will calculate and show you, which is equal to, you want me to calculate, I will calculate, sir. Which is equal to, just put this command. Okay, see, one more thing. I'm not converted into log actually. I am using the direct data. Okay, this gold price I am using directly. Okay, so here just I'm converting into first difference. Return means there are two formulas for it. You can multiply by 100 or even you can calculate return without multiply by 100. Okay, multiply by 100. Okay, now how I'm going to do this value present minus previous. So this is returns. I got it. No, this, you just double click this, you'll get the same value. That's it. So this is returns. The difference between these two, present minus past. That's it. You can see, man. See, sir, you can see here. A3 minus A2. This is the returns. Okay.
Sir, usually we will do the formula like that. Present minus previous divided by previous.
Yeah, previous into 100.
Into 100.
Go ahead. Nothing wrong in that.
Okay. So either we can do the present minus previous or present minus previous divided by previous into 100.
Into 100. That is also you can do. Okay, sir. This can be applied for share price, stock price returns, or Nifty returns. You can apply. There is 2-3 formulas that are, people are applying, 2-3 experts are applying 2-3 formulas. So I'm using this one. This is first difference. Okay, this is a return basically. Okay, change. Okay. Now gold price and returns. So let me go to e-views. Let me see. First, let me go to e-views. Let me open the file. ARIMA, Control C. Can you able to see the screen?
Yes, sir.
Yeah, good. So sheet 1, yeah, it is there. Finish it. No. Okay, so I have downloaded. You can see the gold price here. You can see the gold price here, and in fact written here. Why I copied, I'll tell you. Okay, just I can copy both the series. We'll see when it will be, which one we can forecast. That is decided by the I. Okay. Now, first process, please make a note. First process, what you have to do. First process, what you have to do. We have to identify I. Okay, identify I. I means the order of integration. Order of integration. Okay, fine. So how to find out the order of integration? If this series is stationary, if this series is stationary at level, so I is equal to 0. Order of integration is equal to 0. You able to follow?
Repeat, sir.
No, I'm asking, able to follow?
Yes.
Yes, sir. Yes, sir.
Yeah. Please.
Yes, sir. Repeat, sir.
That's what I asked. Okay. If 1 minute, can you able to see this file? Word file?
Yes, sir.
Word file.
Yes.
Okay.
Yes,
If more the see how promptly you are replying, I will finish all the topics. Otherwise, you are the loser. Please. Okay. So please respond to my question. Reply. If this, otherwise you are the loser. Okay. It's not me. Time is going. Okay. Okay. If the series, please make a note. Order. I'm talking about the order of integration. First integration process. Okay. Let me keep one. If the series is stationary level, I'll show you level. Okay. Level. It is said to be said to be integrated. That means integrated at order 0. Please make a condition. This is 0. Second, if the series is stationary at first difference, it is said to be integrated at order. Anyone? Order?
One, sir. One.
Order 1.
1. Good. I'm just testing. Okay, good. So this is the condition. So order 0. In this case, your I. In this case, your I is equal to 0. In this case, the I is equal to, anyone? I equal to? 1 over. Okay. Now you would answer my question. When integration of order 0, the ARIMA becomes?
ARMA.
The ARIMA becomes?
1.
ARMA. The ARIMA becomes ARMA. Okay. If the series is stationary, at level, it is said to be integrated at order 0. So I equal to 0. So ARIMA become ARMA. Able to follow?
Yes, sir.
Yeah, very good. So now come to the next case. If the series is stationary at first difference, okay, I'll show you when I'm doing the unit root test. If the series is stationary at first difference, it is said to be integrated at order 1. So then ARIMA becomes, any idea? ARIMA becomes?
ARIMA.
Yeah, beautiful. Same thing. ARIMA becomes ARIMA. Nothing changed. So in between, I'm going to change this slightly for your understanding. AR0MA. Okay, 0 stands for I. Okay. So ARIMA, AR. Can you tell me what is the value in between?
1.
1 over. Yes, this is 1 over. Now, first process in ARIMA, you have to determine whether the order of integration is 0 or 1. Number 1, please make a note. Second, exact lag of AR exact leg of MA. That is parsimonious model. We call it as parsimonious model. Okay. Otherwise, there will be loss of information. Okay. So just go to, please unmute participants. Please unmute. Please unmute. Okay. Okay. Now go to, can you able to see these e-views?
Yes, sir.
Yeah.
Yes, sir.
Yeah. Now go to quick. First step, go to quick. Series statistics. I'm going to click series statistics. There is something called unit root test, stationarity test. Okay, I'm just clicking unit root. It is asking series name. It's gold price. Click OK. So it is asking. It is level. Level means 0. First difference is 1. Second difference is 2. Okay. So here level. Intercept. Let it be. Don't change anything. Okay, this is ADF test is going to determine your order of integration, stationarity, no condition. Okay, I'm going to click OK. Can you tell me the answer now here? What is the answer I got? This is ADF test. You know what is the ADF test? Augmented decay.
Sir, can you show the last step?
Hello.
Go to quick. Again, repeating again. Go to quick. Unit root test. Type gold price. That is our time series variable. Click OK. Have you able to see this dialog box?
Yes.
Yeah, it is in level. Automatic. Don't click anything. It is in level by automatically. Don't do anything. Can I click now?
Yes.
Participants, can I click now?
So here no need to specify.
No change anything. No, nothing. This is after all. See the word I'm using. After all, a stationarity condition. That's it. Because there are some tests, no need. Even Granger causality does not assume this. No, assume that stationarity, all the variables are stationary. ARDL mod does not require any stationarity test. Okay, then after all, this is a stationarity test. Okay, fine. Now come to the ADF. ADF, you just keep as it is. Don't change anything. Okay, click OK. I got a result. You know how to interpret this result. The null hypothesis. This is ADF test. Please make a note. This is ADF test. The null hypothesis of anyone, can anyone tell me this? What's the null of ADF test?
There is a unit root in the
gold price.
Data is not stationary.
Simple. Why you are discussing about unit root? No unit root. Simple. Very simple.
Null hypothesis gold price as a unit root.
No. Why you are telling even unit root, sir? Simple, sir. It's not stationarity. That's it.
It's not a stationary.
Yes, sir.
Okay, anyhow, see, you understood, no? This is non-stationarity. The series is not stationarity. Okay, fine. What is the alternative? You understood, no? What is the alternative? The series is found to be stationary. You got my point? Participants, you got my point. Null means, null means it is non-stationary. Why, sir, you are going for complication, unit root? Then somebody will surfing and say, what is unit root? That is connected to mathematics. Unit circle it will show. Then it have to go for less than 1.
Thank you, sir. Thank you. I got it.
Yeah, no, sir. Then I have to go and explain. No, I have to show a derivation part and I have to explain. Okay, simple. Non-stationarity. That's simple, not stationarity. And what is the alternative? That is a stationarity condition. Okay, fine. Now, here, I told you in the morning, there is a mantra. There is one mantra, or might be the rule of thumb. Okay, you people know that. If the probability value is less than, 0.05, you have to reject the null hypothesis and accept the alternative hypothesis. Okay, fine, very good. So now you can see the probability value, it is 0.86. So what is the condition? Is it series is stationary or non-stationary?
Non-stationary.
Yeah, we have to accept the null. It is non-stationarity. Okay, very good. Okay, now after this, what you have to do? You have to go for first difference. How to go? Just same process, quick. Easy to understand. I will go shortcut, but I don't want to go unit root test. Same thing. Some people know new to e-views, maybe for them. Okay, gold price. Click OK. Now you have to click first difference. Then click OK and see. Now tell me the result. Is it stationary or not?
Stationary.
It is
because the probability value is highly significant. No, the probability value less than 0.05. So it is 0.00. Very good. Okay, so fine. So now, can you tell me the order of I? Is it 0 or 1?
One,
The
sir.
One because I have used the first difference, the term first difference. So first 1. Okay, order of integration is 1. That's it. So now I identified my 1. Okay. The next what I'm going to do? What's the next step in ARIMA?
The order of P and Q.
Yeah. That is the biggest, the toughest problem is order of AR and MA. What I'm going to do? Okay, listen. Now, but anyhow, you try to understand the modeling part. That is more than sufficient. Now, what I'm going to do? I can't use gold price now. I have to use only the returns. You know why? Why?
Because series is non-stationary.
Yeah, the series is stationary at first difference. Okay. You understood, no? Sugasini madam, are you there?
Yes, sir.
Able to follow?
Yes, sir. Yes, sir.
Very good. Okay. Okay, now go to what I am going to say now. You should not use gold price because it is spurious. Spurious means non-stationarity. So we have to use first difference data, which is stationary. That's a part and parcel of the ARIMA. Okay, very good. Now let me close this. Go to please this. I'm going to identify parsimonies model. Please, you have to answer me. Otherwise, I can't proceed. I have to wait. Then otherwise, time runs. Okay, time is going on. Okay, estimate equation. Take a pen and note. Estimation. So I'm going to use the returns.
Sir, once again, we start from the beginning, sir.
Okay, I'll start, sir. Can I? Okay. So okay. Go to quick. Estimate equation.
Estimate equation. Sir, we could not remember everything. We are writing. That's why.
No, no problem, sir. No problem, sir.
Estimate equation then.
Estimate equation. Click OK. You know, there is something called Pareto optimality theorem. Those who studied PG in economics, they know that.
Yes.
Without making someone better off, you understood, no?
Yes.
Without making
Pareto optimality.
Worse off. So always that is always the case, but still I want to do the justice for everyone. Okay, at the end, no, I'll tell you what you're supposed to do. Okay, to be better off, everyone to be better off. Okay, fine. So now, as sir said, I went to again. I will go to quick estimate equation and go to sorry, I can't use gold price now. Returns. C means constant. Okay, intercept AR1. MA1 over. So this is called as which model? This is which model? ARIMA model. What is the term? Can you explain? Can you write in terms of expression? ARIMA.
Sir, why we are using ARIMA here?
Forecasting. We are using for ARIMA for forecasting. Okay. Can you able to see this screen? This word I'm typing.
Yes.
ARIMA 1. So my next exercise, after identifying the integration, my next exercise is parsimonious model. Spelling is wrong, but no problem. Parsimonious model. Okay, parsimonious model. PAR. Okay, this is the model. Okay, this is the spelling. ARIMA model. This is the first model I'm going to try with. ARIMA 111. Okay. Second, I'm going to try with ARIMA 211. Why I'm doing, I'll tell you. 3, ARIMA 311. Okay, please make a note. I will ask a question. Why I am doing this? To identify the parsimonious model. How to identify parsimonious model? Appropriate lag length of P and Q. Okay, that is the exercise I'm going to show you. Basically, ARIMA model is used for forecasting. Okay. So can you able to see the EView screen now? Participants?
Yes,
sir.
Yeah. Now,
Yes, sir.
returns is a function of C. Okay, constant AR1, MA1. Now I'm going to click OK and see. Okay. Now don't consider the sigma square. Sigma square, it recently inbuilt option, not required. This is a variance square, not required. So now you can go with the first two component here, which is most important. Please may have a look. The first two component, AR1, MA1. Is it significant?
No, sir.
No, sir.
Tell me, see the probability value.
No, sir, no.
No. So this model is not a best model. Because what is our aim? What is our aim? What is the basic slogan of phrase of the ARIMA model? The logic behind ARIMA model? The YT is influenced.
Explain the present.
Yeah, YT is influenced by past value. So not only that, past values of MA. If that fails, this model is not fail. This model is fail. If that is not happening, this model is completely failure model. So you should throw this model in the dustbin. Yeah, seriously, I'm telling you. No, what is the point when AR is not significant? The model is not significant, sir. Here, the AR1 is not significant. The market is efficient. You can't beat the market. You can't reap the profit. You can't strategize. You can't impose any trading strategies. So Indian market is not efficient market. I can't. I'm telling you. Okay. Anyhow, this is the experiment. AR1 is insignificant. MA1 is insignificant. Now I am going to next model. What is the next model? I told you to make a note. No, professors, please come on. What is the next model?
211.
211. Let me try with 211. How to do? Return C. Just change the order. 2. Already 1 only. Again 211. Okay. Just change the order. 2. MA, let it be 1. Okay. This one already integration is common, right? Okay. Click OK and see. Is it significance?
MA is
significant, whereas AR2 is insignificant. Okay, just throw this model in the dustbin. Come to the next one. So you have to. This is called as trial and error. Trial and error. Okay. So next 311. Or let it. I will do one thing. Okay, we'll try till some model. We'll see for understanding. ARIMA. Can I go for 212? We'll try. No, 212. What's the problem?
Yes, sir.
212. ARIMA, like that, hundreds of model you have to try. That is a difficult thing of ARIMA model. 313. We'll try and see. Okay. Now I am going to, like that, you have to do n number of model. I am going to change this as 2. Click OK. Wow, what is the answer here? Is it okay?
Both are significant.
Sir, once go back, how you have defined the return C?
Return C means, see here, returns. See, just I change this AR value, AR2, that's it.
AR, MA.
Just trial and error to identify the parsimonious model.
Okay, sir.
Click OK. Then please make a note. Both the values are significant. Please make a note. Please make a note. Please make a note. Otherwise, somewhere we'll lose. So AR, both the values are significant. Make this value. Please make a note of this value. AIC. Please make a note of this value. AIC. Someone please help me. 10.89245. Okay. Then can we go for next model to identify parsimonious model? This is the best model. This is a good model because this is because both the coefficient, as per the expectation condition, both the values AR2, MA2 are significant, and I told you to note this AIC value. Okay, now go to estimate. I will try with 3, 3. Just simply, no, I'm just trying with, but you have to try one by one. Okay, this is not a good model. Why? Can you tell me why this is not a good model?
Insignificant, sir.
MA is not significant.
Yeah, MA is insignificant. So go to estimate and try with 4, 4. Simply, I'm just 3, 1, 3, 4. This is a trial, no? That's 4, 4 model. Oh, this is very dangerous. No? Check. Okay, we'll go for
2, 2.
2, 2. Okay, let me go with I have something. Okay, madam, I'll go for 2, 2. As you said, we'll see. This is the way it will run. ARIMA, this is to understand ARIMA process. This is the work you have to do. Then only you can understand. Very good. 2, 2. Please make a note. What you have to make here? 2 values are significant. Make a note of AIC.
P and Q.
AIC. Please make a note of AIC. What is the previous estimation model?
Same, sir.
Yeah, same value.
That one was 2, 2 only.
No,
Yes, sir.
earlier also we did 2, 2 only.
No, sir. I am asking you, what is the earlier model?
The earlier model is also 2, 2. Now also we try 2, 2 only.
Oh, madam. Okay, let me try with 5. Nothing wrong. We'll try with 5. Okay, this is the way ARIMA works. Okay. Oh, very bad, very bad, very bad. 3, 3, 3 we done. 3, 1, 3, 2. Something we have to do. Yeah, very close. 3, 2, 1, 2, 3, 1. We'll try with 3, 1. Wow, I got it. Okay, not on this model. Yeah, this one. This is, what is the model here? 3, 1. 3, 1. Yeah, 3, 1. Okay, please make a note. What are the 2 models is fit? 3, 1. Let me go for 6 model. ARIMA, which is the model here? 3, 1, right?
Yes, sir.
Okay, 3, 1. So out of the 6, what we ran, which model are good models?
3, 1.
3, 1, 1, 2, 2.
4 and 3.
4 and 6.
4 and 6.
4 and 6.
Sorry.
Now, you have to do this trial process till 50 times, 60 times. This is a process. This is known as ARIMA process, Box-Jenkins methodology. Sometimes people are using spiky method, autocorrelation function. Okay, that is not reliable, basically. If you ask me, that is not reliable. Number 1, that's a traditional method, shortcut method. Now there is an inbuilt software. Okay, inbuilt software. Automatically, EVUs will run and give you the parsimonious model. Okay, that is recent EVUs have that features. Okay, I have not tried, but for understanding ARIMA, this is the best approach. This is known as trial and error process of identifying parsimonious model. Okay, fine. Now come to the 2 models. Can you tell me what is the AIC value for this one? AIC value 2, 2 AIC value 2, 2
The
AIC
10.89.
10.89 full.
2, 4, 5.
2, 4, 5.
4, 5.
10.89.
So here come to this one, 10 point
96238.
238. Good. Is it correct? Okay.
4 is best, sir.
Now, which model is the best model? Is the least error minimizing criteria? Morning I told you this is the error minimizing criteria. Which model is the best model?
4th, sir.
4th one is the best model. So this is the parsimonious model.
Minimum AIC must be considered.
Yes, sir. I hope you are clear, correct? That's it. But problem is, I have tried, no, 1, 2, 3, 4, 5, 6. You have to try like some kind of 50 times, 40 times, identify parsimonious model. This I have taken 212.
Sir, how can we interpret this identification process?
This is not a interpretation. This is identification. Normally, you have to do. No, you want to explain this one, the table.
No, sir. Actually, how did we come to this? Like, we chose this is the parsimonious model. So how will we explain this?
Okay, two conditions. Two conditions to identify parsimonious model. One is A. One is
archaic information.
No. Significance of. Yeah, correct. Significance of AR and MA terms. This is known as Box-Jenkins methodology. Process. ARIMA is a process. It's not simply, we should not, simply we can't estimate. We can't, forecast. Okay. Significance of AR and MA term. That is the first one. Second thing, AIC. Compare after identifying how many models. Just estimate, some around 20 models. Depending on your sample size, 20 models, depending on your sample size. Okay, good. So, there are 20 models you are estimating, find out significance, then go for AIC. I told you in the morning, what I told you regarding AIC in the morning?
Sir, either a model comparison in either criteria.
Yeah, that means when you want to compare two models, usually people will, econometricians will refer R square value. But in fact, you can refer by AIC and SIC also. Okay, these are the error minimizing criteria. Okay, very good. Now AIC, I explained, I got two values through AIC. Okay. Madam, someone asked this question, correct? Are you clear to identify the parsimonious model? Yes, sir. Thank you. Okay, now what you have to do, I'm putting in highlighting a red color also. Okay, fine. Now, so in our case, which is the parsimonious model? 212. Okay, 212. Okay, now I told you this is the model. 212 is a model. Okay, 212. Estimate 212. One is already defined integration. This is 2. Okay, this is the parsimonious model. Okay, now I told you several times this ARIMA model is used for forecasting. Okay, fine, forecasting. Now, can we do forecasting? Can we do forecasting? Yes. Hello?
Sir, we can forecasting, but how?
That I know that. I'm going to teach you. Can we proceed or not? I'm asking to the
Yes,
participant.
sir.
We data is significant. That's why we.
No. I'm asking very simple. We identified parsimonious model. Can I go for forecasting? I'm asking you. If you say yes, I'll go.
Yes.
Very good. So I'll show you how to forecast. See, please note the number of observation. It is 140. Please make a note of observation. It's 170. 170. Sorry, 170. Okay, now I want to go for forecasting just next 5 observation. Don't go for long predictions. It leads to failure. Okay, participants, please don't go for long predictions. Okay, don't feel happy that
Sir, but hello, sir.
Tell me, madam. Pooja, madam, tell me.
Yes, sir. Sir, you said that no go to the long data, but means minimum data is 1 year, 2 year. If
No. What I am suggesting, please see. I'll tell you. The role of the RBI, the main function of RBI. Okay, I'll put it in this way. If you go and click the RBI, if you go and visit the RBI website, you have seen a lot of reports, correct?
Right, sir.
You can see, the predicted values, they will put in P, provisional. Have you seen it in the superscript?
Yes, sir.
They're
Yes,
provisional. Even they are using the statistical analysis and they forecasting for how many years? Just next year. You understood? No. because in between there are many shocks occur. You understood, no? Many problems may come.
Right, sir. I understand. I get it.
So please, okay, that we can't count because we are using just an ARIMA model, okay, which is a linear model. Okay, please make a note. This is linear model. ARIMA model is a linear, it's not a non-linear model. Okay, so just we can use this model to some extent, like 3 days or 4 years or if you are using annual data, 1 or 2 years, maybe 2 years you can see. If you are using share price daily, maybe 10 days or 1 week you can see. That is a reliability. No, I can tell you from my expertise, I can use my expertise and tell you maximum. Don't go for the curiosity, sir. Next 5 years, next 10 years, please. It won't work. Okay.
Right.
This is ARIMA model. ARIMA, I'll tell you one thing. ARIMA is ARIMA. Hope you understood. Okay. If you read, no, you come to ARIMA is ARIMA. This is linear model. Okay. How many of you calculated beta? How many of you calculated beta in CAPM model? Using CAPM model, simple regression. Professors, I'm asking you, CAPM model, you calculated beta for the stocks, no? Professors, I'm talking to you. How many of you calculated beta of the stock using
Yes,
simple regression model, CAPM model?
Yes.
Okay. Can I rely on that beta to invest my money?
Please.
Huh? Be bold, because what you are estimating all are constant beta. It is not a time varying beta. You know what is time varying beta? Each and every moment the market is changing. Okay, you are not calculating time varying beta. You are just calculating simple regression model. You are calculating beta, which is the risk factor. See how the example. So same thing. ARIMA is a linear model. Okay, where you can use for maybe annual data 1 year or 2 year maximum. If it is a monthly, another 5 months, 3 months. Okay, that's it. Okay, anyhow, just go to now forecast. How many observations are here?
170.
170. You have to do some exercise before that. 5 observations. Go to from here. Go to object. Not object. Let me see.
Doctor.
I did proc. Okay. Quick. Group view. Proc. Okay, here it is there. Wait a minute. Here view. Yeah, here it is there. Okay, so proc. Now I'm going to do the forecasting exercise. Can I able to see the proc here? Process PROC. Can I able to see PROC?
Yes, sir.
Yes, sir.
Yeah, I'm going to restructure the current page because I'm going to use for the next 5 months. This is monthly data. So next 5 months I'm going to forecast. So what I have to give now here? Next to 5 months, 170 plus 5, how much? 175. I'm expanding that work file for the forecasting. Able to follow?
Yes, sir.
Yes, sir.
So just I'm expanding my space, that's it, nothing else. Previously it was 170. How many months I'm going to forecast next? 5 months. So just 5 months I added. So observation increased to 175. So click OK. It will tell you resize involves inserting 5 observation. Continue. Yes, I continued. Okay, so now go to, just a minute. Okay. Now just go to estimate. Okay, come back to your result. What you estimate 2-2 model. Now I'm going for forecast. Please, I'm going to click the forecast. Just see, please. I'm going to click the forecast. Yes, I've clicked the forecast. Okay, so forecast name, let me put F, future, predicted or forecasted. F, I'm putting F, or you can put whatever the variable, forecast name. Okay, so here, forecast sample, I want to adjust 171. This is 171. Okay, 171. So I am going to let it be. This is dynamic for. Don't change anything. Okay, don't change anything. Okay, just I'm going to click OK. I just sample forecast sample. I have corrected 171 to just 5 month. I want no 171 to 175. I'm going to click OK. Okay, I have clicked. Now just minimize this. Have you seen F here? F. Have you seen F here?
Yes, sir.
Yeah.
Yes, sir. Yes.
Just double click and open. This is actual. Okay, these are all actual returns. Please, participant, these are actuals. Okay.
Yes, sir.
Forecasting started from where?
171.
171 onwards.
This is the forecasted returns. Go to view graph. Done it. Okay. So this is the till 171. You can see here 170 last 5 observations shows the forecasted value. Okay, fine. So if you want to see the sheet, you can see the sheet. Last 5 observations.
Sir, how you got the last graph?
No, simple, sir. Go to view. Go to view. This graph is there directly. Graph is there. Click the graph. Directly click OK. That's it. Okay, this is the last 5 observations. You can see. Okay, so this is about the forecasting exercise. This is about the ARIMA. So now,
sir, one question in my mind.
You can ask many questions, sir. Tell me, sir.
Yes. So we have done the ARIMA for the gold price, then to the return. What is the necessity of doing the gold price? Then we switch over to the gold return.
Yeah, that is, it's not, it's a necessity, sir, because the prerequisite condition for the ARIMA, it completely depends on the process, stationarity process.
So for that purpose only.
Yeah, if you are forecasting the non-stationarity variable, of course, dealing with non-stationarity leads to spurious. Okay, spurious estimation. So that is the reason I'm going for the integrated process. Sometimes I will ask you the reverse question to you.
Okay.
Suppose the variable, let me check your level of understanding. Suppose the variable is non-stationarity, it's a stationarity at level itself. Which one you have to use? Which one you have to use? Returns or gold price?
I can't understand.
If the, please, let him tell the answer. Suppose here the order of integration is 1, correct? So I use the returns, correct?
Yes.
Professor, got
yes,
it?
Sir. Yes, sir. I'm listening.
Yeah. Now, suppose gold price I use for testing, correct? Testing for stationarity. So that is stationary at levels only. And the levels, the price only, the gold price is found to be stationary. So what I have to do? I have to go for ARIMA or ARMA? Which series I have to use?
ARMA, sir.
Madam, please 1 minute. Please let him answer, please. I want to check his level. Okay, tell me, sir.
So when the gold price at the level 1 stationary.
Not level 1. Levels means the I of 0. I of 0.
That's no, at level 1.
Okay, levels. Okay, level.
Level. That is, if it is a stationary.
Then what is integration order? What is the integration order?
Then another ARIMA only, A or MA only.
Here, which series you will use for it? Which series you will use? Return series or gold price you will use?
Gold price series only.
That's what. Okay, so ARIMA is have to decide whether you're going to forecast returns or gold price. It is not that you and me, sir. You got my point?
Okay, it's very good, sir. Thank you.
Very good. I will appreciate you, sir, for your level of understanding. Very good. Okay. Okay, this is about OLS model and
Sir,
ARIMA
one more
model.
thing. One more thing.
Yes, sir.
Suppose if our the gold price at level 1 non-stationary, what we can do?
Level 1 non-stationarity, you have to go for stationarity. No, next condition, first difference.
First difference.
First difference. Yeah, you can go for returns. Even from the returns also, you can come to the prediction of the price.
Okay. Okay.
Sir, technical, sir. Technical, sir. Technical.
Minute,
micro structure. Come on, think. Okay. Any other questions? Please, participant. I'm ready to answer your questions. Tell me anything else. Anything else? Please ask me. I'm ready to answer. Otherwise, we'll move on to the next level.
Hello, sir.
Pooja, madam, I'm here. Tell me, madam.
Yes, sir. Sir, actually, these data which we conclude, is it reliable?
Who step into the moon, right? You know who stepped into the moon? The first person who stepped into the moon.
Neil Armstrong, sir.
Madam, Pooja, madam.
Neil Armstrong.
Very good.
Neil Armstrong.
Okay. People know the Neil Armstrong very well because he stepped into the moon. He's there. Okay. My question is, suppose something happened there to him, some fault. You know who is there to go into correct? You know who is going to sit and correct here? The Einstein who is sitting here and operating him, right? Is going to do rectify the problem. So why I'm telling this? Here we fail to realize the importance of Einstein. Rather, we are focusing only on the person who stepped into moon. That means there is a huge gap between the academics and industry. You understood? Now, whatever we are writing a paper in terms of academics.
Right.
You got my answer, right? You got my answer, madam. The industry failed to follow it. When we are doing academic research, we are publishing n number of articles, right? Do you think that whether the industry expert, the professionals are following this? There is a gap. That is what we call it as industry academia interface. This is very poor. This is very, very poor. When you have to first have confidence on your work. You understand? Yes, you can use ARIMA model to predict the market. Okay, you should have self-confidence so that you can say boldly, yes, you can reliable. If you ask me, madam, I'll tell you, if you ask me, this is a basic model. There are many more models have arrived for forecasting. So we have to equip our knowledge, okay, update our knowledge, because this is a basic model. So you can use, there are many models, exponential smoothing model, neural network analysis, and Garch type of family models. There are many models have come. Okay, so non-linear models have come. So where this ARIMA become failure? If you ask me, model comparison study you have to do to find out which model is the best model. Then you have to boldly, very confidentially, you have to suggest for investors. Yes, you can apply this model for forecasting. You understood, madam?
Yes, sir.
Yeah. Okay. Any other questions? This is the ARIMA model. Please, again, I am telling ARIMA is ARIMA. There are many more models are there for forecasting emerged. Okay. This is a conventional model.
So can you tell us the books, name of books, then we explore all these things related to the financial market here?
No, madam. Instead of telling books, it's better to refer the research articles. That will give you more idea. Research articles.
Books will not give any.
No, sir. Books give you the basic understanding of the standard models. The standard models like, for example. What I am going to cover here, you can refer Chris Brooks is a good book. Okay. Chris Brooks is a good book. You can make a note. Chris Brooks, Time Series Econometrics. Really good book. Okay, or Walter Enders. Walter Ender. WALTER. Walter Ender. ENDER. Walter Ender. It's a good book.
Sir, first one, sir, please.
Chris Brooks.
Chris Brooks.
I am typing here. Just see. Chris Brooks. Next book. Walter Ender. Just type in Google. You can. Walter. Sorry. Ender. Then, as usual, to get the basic essence and basic knowledge, you can find out the Gujarati. Okay. 3 books you can refer to get the essence of time series analysis. Using these 3, you please focus on the article. Okay, that article in your area which have been used for the forecasting, you'll get a knowledge about it. Because nowadays, instead of publishing as a book, they are writing an article on the models. So we are trying to refer articles for the model. Can I say one thing? Have you heard about ARDL model?
Yes, sir.
Sir.
You suggest, auto regressive distribute lag model. This model, there is no book. There is an article called Resaran and Shin 1999, or it might be 2001. The madam asked me this question. I'm suggesting that's it. Okay. So that means the advancement in the time series analysis published in the article comes out as a research paper instead of in the book version. But time series analysis, if you ask me, I can say Chris Brooks, Walter Ender, and Gujarati. In fact, you are really good in mathematics. You can go for Green Model. Those books you can follow. Okay. So please. Okay. So now we'll move to the next concept. Causality. Please make a note, causality test. So OL is completed, ARIMA completed. We'll move to the causality analysis. Okay, causality. Please make a note. Causality test. This is very important.
Excuse me, sir.
Yes, sir. Tell me, sir.
Sir, as you said that the ARIMA model having the problem of autocorrelation problem, right?
Yeah. Yes.
Sir, what about that? The consequence of that in ARIMA model, sir?
No. Okay, anyhow, you reminded that one. Okay. See, ARIMA model is used to forecast the series. Okay, nothing else. Why? What is the logic behind it? YT is influenced by YT minus 1. So see, then as its consequences, UT is also influenced by UT minus. So obviously you will get autocorrelation problem. Okay. So now even there is a problem with the model. What is the model? I'll show you. Okay. This is the ARIMA model. Can you able to see the screen? This is ARIMA model.
Yes, sir. Yes.
Okay, we estimated. Now, even though, so there is an autocorrelation problem. It has to be. That's what I told. No, ARIMA model. If there is an autocorrelation problem, only you can go. Otherwise, no point. That is what the MA is significant here. The moving average term is significant. What it connotes. That means the UT minus 1 is influencing the YT. Understood? That is one of the sufficient requisite conditions. So you're going on that, right? Fine. Now my question is. Final one I failed to say, I forgot to say, the model, the residual of the estimated model should be white noise. Please make a note, the final conclusion. The residual of the model should be white noise. White noise is nothing but they should be free from autocorrelation. Now in the morning I told you what you have to see, whether this model is having a autocorrelation problem or not.
DW test.
DW test, right? Yeah. If you see the DW statistic, it should be close to 2, around 2. Okay, but still you can see this DW statistics, it has 2.34, but this model has suffer from the autocorrelation. So what you have to do? That is what you have to find out the best parsimonious, that the parsimonious model, not a best, it's a best model, as a parsimonious, better model, or the parsimonious model. But when you are estimating, you have to see whether this, if you feel this model is a parsimonious, you have to check whether this is around 2, because the last important condition of the ARIMA model is the UT, the residual of the estimated model should be white noise. So 2.34. So little, there is this model has a problem, but then what you have to do, you have to repeat the exercise. Okay, beautiful diagram. If you go to Gujarati book, beautifully flow diagram was given for the ARIMA process. When, if you found the residual of the estimated model is not white noise, that means it has a problem of autocorrelation, come from the first one. What is the first step? Appropriate P and Q. Okay, but due to time, just we identify this, almost all the conditions satisfied. But thing is, Durbin-Watson test is 2.34. Little, there is small slight problem of autocorrelation that we have to taken care by repeat the procedure. Okay, sir. But otherwise the autocorrelation condition is this is a requisite condition to go for ARIMA model. Otherwise no, you will get insignificant MA. Okay. Got it, sir?
Yes, sir, got it.
Okay, now we'll move to the next. This is very important. Okay, this is very important. We'll go for the causality test. What is the causality test? Most of your PhDs is based on this causality test. There are many causality tests, SIMS, Granger causality, error correction model. There are many causality tests. Okay, so which I am going to touch upon this causality test. Okay, so it's completely.
That come under the co-integration also.
Yeah, that's one of the condition here. Okay, so let me put, okay, causality means even the co-integration also part of the causality test. Okay, sir? Understood, sir? Participants able to?
Yes, sir.
Okay,
Yes, sir. Yes, sir.
Okay, now just I'll take a good example. You will take Indian stock market and US stock market. There are many examples. You can take US stock market. Okay, US stock market. So I want to study the correlation. I mean, correlation means the connection, the relationship between two stock market. Okay, but you know, I can't simply apply correlation. If I can apply the correlation and see, is it highly correlated? No, both the markets will be highly correlated. Okay, there are many examples I can give you. Indian stock market and US stock market, highly correlated. Any n number of variable, okay, FDI and GDP. Okay, for my okay, FDI and GDP. Then GDP and trade. Okay, and trade, sales and advertisement expenditure. There are many. Okay, there are many. Please make this point. These are very important. There are many cases where both the variables are moving in tandem. Move in tandem. Co-movement, I am talking about co-movement. You can apply correlation, but correlation become very older. Okay, so people are applying causality test. Okay, here this is very, very important. Causality test. I'll ask a question, simple question. Sales and advertisement expenditure. Which is the dependent variable? Can anyone say which is the dependent variable? For a simple example.
Sales.
So let me move to the marketing people. Okay, sales is the function of, sales is the function of advertisement expenditure. What do you mean by that? Advertisement I mean, this, can you explain this equation? That means
sales is independent and advertising. Sorry,
No,
sales
no,
is
no.
dependent.
Yeah, sales depends on advertising. How many of you agree? Can anyone agree with this?
Yes, sir.
Yes,
Yeah,
sir.
this is the basic model. Okay, this is the theory, sales theory or whatever it is. Okay, the marketing candidates know that sales is a function of advertising. The other way also we can say that
Advertisement is function.
Then is equal to function of sales.
see the this is what is a function of sales.
Both are correlated with each other.
Okay. Okay, see the functional form. This is number one. This is functional form number one, and this is functional form number two. Understood? No. Now I can estimate only this. This is leads to biasness, which is called a specification bias, because logically speaking, sales is a function of advertisement expenditure. At the same time, advertisement also is a function of sale. You understood? No? What here? The sales is the endogenous variable. Sales. Why sales is the endogenous variable? Why sales is endogenous variable? Any idea?
Because we are estimating only first equation. It is self dependent variable.
Yeah, sales is acting as a dependent as well as independent variable. Okay, this is a simultaneous equation model. At a stretch, we have to estimate simultaneously. So advertisement also endogenous variable, where this is acting as a dependent variable as well as independent variable. So sales and advertisement expenditure are the endogenous variables. Okay, so this is a system. This is a system. This is a system. Okay, so this is a system. Okay, so here causality test. If you come to the causality, I'm talking about the causality, right? I'm not deviated to anyone. Causality test deals with the endogenous variable. Causality test nothing but deals with endogenous variable in the simultaneous equation setup. Simultaneous equation system. That means you have to jointly estimate these two equations, not separately. Okay, you should not estimate this separately. You have to jointly estimate this. Okay, so in fact, moreover, the causality is based on the autoregressive terms or autoregressive terms. What is autoregressive terms? What is autoregressive terms? That means
the dependent variable.
Let's say sales.
Previous sale.
Yeah, sales is equal to function of
previous.
Okay, I'll show the in terms of setup later. First, you understand this. Sales, previous sales, as you said, -1, right? Past sales, and what? And what? Tell me, advertisement expenditure of what?
This year, sir.
Yeah, previous. That's it. That means the present sales is influenced by the past value of advertisement expenditure. Okay, when you say causality, it deals with the past values, AR terms, the past values of the other past value of its own as well as other variable. So this is the setup.
Sir, please one more time, sir. Please, sir. I didn't fully catch that one.
Sales. Have you understand this concept? Sales and advertisement are the endogenous variable.
Sir. Yes, sir.
Yeah, come to the next I'm explaining.
Yes, sir.
The causality test has been conducted based on the past values of the dependent variable as well as the other variable. That means the other variable, no, like for example, sales is equal to, sales depends on its own lag. Got it, sir? Its own lag. And the lagged value of advertisement expenditure. T minus 1 I am talking about. This is T minus 1. You got it, sir?
Okay. Okay. Yes, sir. Yes, sir. Thank you very much.
Excuse me, sir.
Yes, sir. Tell me,
Excuse me, sir.
Yes, sir.
Sir, if you don't mind, actually yesterday Mikhail sir already told that if dependent variable, the taking the lag of previous year and independent variable also taking the lag of previous year, then that is called autoregressive and distributed lag model,
No,
right?
I'm not teaching you autoregressive distributed model here. Both are endogenous variable. I am taking the sales is influenced by its own value, autoregressive terms, as well as the lagged value of the other endogenous variable, the other variable.
Okay, okay, sir. Okay, sir.
You understood, sir?
Yes, sir. Yes, sir. I thought
don't confuse with ARDL. ARDL model can be run with a single equation setup as well as endogenous setup. Autoregression, sir, please. Autoregression model can be run in a single equation setup as well as simultaneous equation setup. Okay, don't confuse with ARDL model here. Okay, that if time permits, I will complete that. Okay, please here. Purely, I am talking about the endogenous variable. This is the point, endogenous variable. So here, sales and advertisement are the endogenous variable. So sales is influenced by its own value and also the other endogenous variable. As sir, this equation, the causality model, the specification is completely based on the theory. Okay, that is what I have taken sales and expenditure. Can you agree? Can anyone agree? Okay, let me say US stock market is influenced. Okay, can I say Indian stock market is influenced by US stock market? The past moment of US. Yes. At the same time, what is the guarantee that the US stock market also influenced by the past value of Indian stock market? So, if you go for a single equation setup, you will end up with specification bias. So you have to estimate, okay, you have to estimate simultaneously. That is what the causality test is completely, comes under simultaneous equation model, SIM. I'm not talking about structural equation model, simultaneous equation model, okay. Here in this particular time series setup, okay, SIM, simultaneous equation. Simultaneously, you have to estimate because both the variables are endogenous. Okay, now let me come to the point. What is the other equation? This is first equation. What is the other equation?
Sir, advertising expenditure.
Yeah, beautiful. Advertisement expenditure, which is equal to function of
advertising expenditure previous year.
Yeah, okay. Advertising expenditure of previous year. T minus 1.
Comma. Sales T minus 1.
Comma. Sales
T minus 1.
T minus 1. Here, endogenous setup. This is called as endogenous setup. So this is true. Okay, over. This only we are writing in using alpha, beta, theta, all equations. But in terms of functional form, this is the functional form. Okay, I have to you understood, no? So this is, if you expand this, let me show you on PPT. Okay, now you can able to understand what exactly it was. ACT, FDP, ordinary school method. Okay, I'll show you on PPT. Then you can able to understand what exactly this setup is. Okay, can you able to see the PPT? Participants?
No, sir.
No?
No, sir.
Can you able to see now?
Yes, sir.
Okay. These are all we have discussed. Okay. This is the single morning what we have discussed, no single equation model. Leave it. Okay. Now see, one example I want to tell you. See this equation. Can you able to see these equations?
Yes, sir.
What do you mean by that? What do you mean by that? Someone asked me the question. What do you mean by this? This is a causality setup.
Yes,
yt is a function of yt minus 1 plus xt minus 1. xt is a function of yt minus 1 plus xt minus 1. That's it. This is the OR model. Vector auto-regressive model. What I explained to you is a vector auto-regressive model. Got it? Why it is vector? Is nothing but more than one equation. More than one equation, we call it as vector autoregressive model. If it is one equation, we can call it as autoregressive model. If it is more than one equation, so that's what I told you. Just read this slide. Vector autoregressive model allows the feedback, reverse causality. Sales is not only influenced by advertisement, advertisement also influenced by sales. So that means dependent, independent regress are using their own past values. Okay, both are endogenous variable. No exogenous variable. If there is exogenous variable, there is a possibility in ARDL setup. Okay, that we'll see. Here there is no exogenous variable. Okay, fine. So endogenous variable. Okay, you understood, no sir? Able to follow? So this is what I'm explaining. Even if you go for error correction model, same setup. Okay, even if you go for error correction model, also same setup. Okay, this is the base. This is VAR model. What I have written is a causality model. Begin with the VAR model. Okay, I just show you 1 minute. Share screen. Where here. Okay, this is what I told. This functional form. This is functional form. This is called as functional specification of functional form. Okay. Now, what you have to do? What is the first step to apply the causality? Okay, to apply the
unit roots.
The causality. So there is a procedure in time series econometrics. There is a procedure. First one is unit root. The second one is there is a procedure. Please make a note. There is a unit root. Then VAR model. VAR model. Please make a note. Unit root, VAR model. Granger causality model. There is a procedure. You just make a note. Granger causality test. Co-integration. I put one underline. There is a reason behind it. Co-integration. Vector error correction model. This is what we are going to study. VEC model. VEC means vector error correction model. That's it. Okay. So this is about the causality procedure. This is about the causality procedure. Okay. So these three I'll put in different color. Last two I put in a different color. Okay. Fine. First we have to start with unit root. Okay. First we have to start with unit root. That is going to be decide which model you are going to do. Okay. First thing you have to start with unit root. That decides whether you are going for VAR model or Granger causality model or co-integration or error correction model. Okay, you understood, no? Participants able to follow?
Yes, sir. Yes, sir.
Yes,
So
sir.
yes, sir. Yeah, the starting point is unit root. Yeah, the starting point is unit root test. The unit root test will decide whether you are going for the causality model, the autoregressive model, or the Granger causality, or you can going for error correction model. Okay, co-integration is a part of error correction model. Don't forget, the co-integration is a part of error correction model. That's it. So this is what I'm going to do. Okay, so
after the unit root test, we can do either or only, either VAR model or Granger causality.
Yeah, correct. No, correct.
Or via the VAM model only.
Yeah. That is what I will do. One thing, I will put this is 1 and this is 2. Okay, any one model. 3, either 3 or 4, and even this is 2 are common. This 2, this is 3A and this is 3B. Sorry. 3, let me put this is 3A. Let me put 3A. That's the best. 3A and 3B, because both are combined. Okay, 3B. If you're going for co-integration, you have to go for vector error correction model, combined. Okay, combined, please. If you go for unit root, you can go either var model or Granger causality model. Anyone. So I can put slash. I'll put in this way. Okay, now it's clear, right? So the deciding factor is unit root. Please make a note. The deciding factor is a deciding test. The deciding test is unit root test. Okay, unit root test is deciding factor. So based on the order of integration, we are going to decide whether we go for a var model or Granger causality, might be co-integration or error correction model. So what is the deciding factor? Unit root test is a deciding factor. In fact, I can also go for ARDL model also I can go. Okay, apart from this fourth one, you can also try with ARDL. This is separate. Okay, if you are not going for this co-integration vector error correction model, this is the another model. Let me put a line. Okay, this is another series. Okay, so ARDL model is another one. Please make a note of all this. This is another model, green color. Okay, so we have to start with unit root. Then we have to decide whether we can go for var model or Granger causality, or we are going for co-integration or error correction model, or we can go for ARDL model. We can decide. The starting point is unit root test. Now let me go one by one. Just I'll show you. Let me first finish unit root, then we'll decide. Okay, so how many variables are required for the causality? How many variables are required for the causality?
2 variables, sir.
Yeah, 2 variables. That's what we are discussing. Correct? Okay. So let me. I don't know. Okay. ACT folder. I got the causality. Okay, 2 variable I got. This is GDP. Okay. So you can see, no? Can you able to see? You can able to see the screen? Yeah, there are 2 variables. One is GDP. The other one is public expenditure. Please make a note. I have taken one is expenditure. The other one is GDP. Okay. Any 2 you can also take, not a problem. Here I have taken public expenditure, GDP I have taken. Okay. So now I have converted this into log. That is LP.
The screen is not visible.
Screen is not visible.
Sir, we are not seeing screen, sir.
Can I able to see now?
Yes, sir.
Okay. Now you can see there are 2 variables. Okay, in this eViews file, there are 2 variables. One is public expenditure.
Sir.
One is the public expenditure. I could not able to hear him. Okay, one is public expenditure. The other one is GDP. Okay, just 2 variables I have taken. You can take any variable. US stock market, Indian stock market, spot market, futures market. Okay, you can take export and GDP, sales advertisement, and sales and advertisement. You can take any number of variable. So I have taken for explanation, I have taken public expenditure and GDP. I have converted into log. Okay, I have converted into log.
For the causality test,
can we take more than? Sir, can we take more than 2 variables?
Sir, can you type in the chat box so that I can see? Tell him to type in the chat box, please. I will see what exactly what is asking. I do not able to hear him. I could not able to hear him. Okay, fine. Please type in. Let him type in chat box, please. Okay, fine. Now these are 2 variables I have taken. You can take n variable, n number of variable, x, y. You can take any example you can take. Okay, fine. So now let me, sir, can we take more than 2 variable? Of course, yes. He's asking. Yes, sir. Let me type yes, sir. Okay. So good question. So what we are doing here, it's a bivariate analysis. Why it is a bivariate? Anyone? Why it's a bivariate? How many equations?
Two equations are here that is called the bivariate.
Yeah, two equations is a bivariate. If it is more than two equations, it is a multivariate. So that sir is asking, he's from other country it seems, he's asking, can we go for one more variable? If we go for one more variable, say let's say for example, I have taken Chinese market, Indian market, Chinese market, US market. So that I have to estimate under multivariate setup. So what I'm explaining is a bivariate. Hope you got the answer. You can do. Okay, you can do causality test. So causality test in a multivariate setup. What I am doing is a bivariate. This is the base. This is the base. Okay, you can keep even 4 or 5 variables also, and you can do. But provided all should be endogenous variable. This is what we have discussed. No. Okay. What it told me. Okay. So let me go to two variable. What is the first step I told you? What is the first step I told you? What I told you?
Converted into log.
No, that already I converted. So LPE, LGDB. So let me delete the other variable. Easy to understand.
Sir, how to convert into log, sir?
Sorry, sir. Even when I'm eating lunch, I thought of you.
No, why? Sir. You stated that we can do after that.
That is what, sir. That is what while eating lunch, sir, I thought of you. That means I thought of not to explain to one professor that I need to convert how to convert into log. That I forgot even now also. I'm sorry. That I'll do it now only, sir. Okay. Now look at this series. Can you able to see this? Thank God that you reminded me, sir. Thank you. Okay, sir. You just can you able to see this series?
Yes, sir.
For example, you take. Let me delete this. This is a gold price. Okay, I'm going to convert this into log. Okay, let me put this as a G. Okay, G. Generally, you can put any name. I can put G. Okay, equal to ln. Open the bracket. Click on it. You understood, no, sir? Can you able to follow?
Yes, sir. Yes, sir. Yes, sir.
Then close the bracket. Over. So double click on the edge, the corner. So you will get ultimately. So if you want to check, I will show you. See, all 170 observation you can see. Got it, sir?
Yes, sir.
Sir, can I repeat again? Equal to?
Yes. Yes, sir. Yes, sir. Please one more time.
Equal to ln. Open the bracket. ln means natural logarithm. Okay. Click the value which you want to convert into log. Close the bracket. Enter. Click the cursor on the value which you have converted. Just drag or double click. Automatically it will be filled. Okay, sir?
Thank you, sir.
Good. Can I proceed, sir, now?
Yes, sir.
Yes. Beautiful. Yes. Beautiful. Okay. Okay, now come to the point. I have already converted. Thanks, sir, that you reminded me. I thought of even my lunch also. I could not able to show that. That's a very basic thing. Okay. Okay. So LPE, LPV. Now you can able to see the graph. No. Okay. Sorry. See the sheet. Okay.
Sir, question. What is the advantage of converting into log?
That is what I told you, no, sir. Without conversion also you can do the econometric modeling. No one denied that. What is the advantage? Because we can normalize the data to reduce the standard error. Because the stationarity, if you look at the stationarity, what is the meaning of the stationarity? Because what is the meaning of the stationarity? Stationarity is nothing but the mean reverting process of the series. Okay, that means the variance and the covariance, mean, variance and covariance of the time series should be stable. You understood, no, sir?
Yes, yes, sir. Now I understand.
Yeah, so we are
better we are using the log for reducing the standard error.
Yeah, normalizing. Use the word standardized or maybe not a standard, normalizing the series. Okay, sometimes what will happen, one series will be indexed, the other series will be in ratio, the other series will be in, you understood, no, sir? In yes, some other measurement. So it's better to have a natural logarithm which you convert into everything we are normalizing. even though it has a different units of measure. There are many advantages on that, but still there is no compulsion that you have to go for log. So you can go for normal as usual. But what is the problem? Mishra sir, please mute yourself, please. So now what is the problem? Okay, so what is the problem? You study the OLS model, the best unlinear, that there should be minimum variance criteria. One of the best, blue property, best linear unbiased estimator, we should have a minimum variance, the data series. Okay, so it is better to normalize to reduce the deviations, that variance. Okay, so there are many advantages on it. If you want to convert it. Otherwise, you can go with that as usual. But it is better to convert into log. Okay, fine.
Sir, in case of finding the, in case of forecasting the return, if the data are not converted into log, then only we can get the original.
Yes, sir. That is what, sir. Here, ARIMA process, I want the stationarity. 1 minute, sir. I want the data series should be stationary. Okay, sir. So directly I have taken gold price. Okay, sir. When I am converting into first difference itself, it's a normalizing. You can see the value. So I can able to prove it, no? You understood, no, sir? See, what is first difference, no? You are reducing the variation. Even you are subtracting, right? With the present with the previous. So it's a difference, no? It's a difference, it changes, which the absolute value become very less. Have you seen this?
Correct.
So ultimately, I can able to prove even that's what even you can go with the direct stock price. I have directly gone with the stock price. No, you can convert into log, and you can go. It's not a problem. But one thing. Even as you said, no, even if you convert into log also, you can go for the returns. Nothing wrong. That is what, no. Sir, finding out the returns, there are 3-4 formulas. One is, as you said, as me said, even using a log also, you can convert into returns. Okay, many articles, a finance article, you can see, they're converting returns using a log. Nothing wrong with that, but only thing is, you should be aware of the conversions, how to convert log into returns, return into log, return into price, price into returns. That conversion you should know. You should be clear. You understood, no, sir?
Sir, another here. Suppose I am writing one article. With I am doing the descriptive statistics also. Then the normality test also. Then with ARIMA. Then with the casualty, I am ending. Just one imagination. So the descriptive statistics with stock with the stock.
Hello? 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 Can you able to hear me?
Sir, I think he got some problem.
Okay. Let me, okay, I will do one thing. Today just, I'll show because already time up. Just I will show you how to do the unit root test. We will discuss further in the next class tomorrow around 11 o'clock. Okay. So let me show how to conduct unit root test. This is I converted into log. Please, participants, please make a note. Just as I said, go to view. Okay, nothing. Just go. Okay, I'm sorry. Okay, go to view. Okay, go to quick. Sorry, go to quick. It is a series statistics. The unit root is for the series. Okay, click series name. LGDP. Okay. So you got ADF test. Start with a level, first difference, second difference. So I just click level and intercept. Let it be, as I said earlier, click OK. And you can see it is 2.59. 2.59. Okay. So is it significant or insignificant?
No, it is non-significant. Insignificant.
It is significant. It is not significant. Why means I'll tell you. This is less. This value is less. Forget about p-value. Sometimes this will happen one. Okay. You compare this t-value with the critical value of 10%. So this is less. Calculated value is less than the critical value. Okay. 2.59 and 2.60. So we are accepting the null hypothesis. So we have, this is not stationary. So what you have to do, go to quick series statistic unit root test. Okay, with the unit root test, I'm going to go for LGDP again. Okay, so it's the first difference level. It is not stationarity. I'm going for the first difference. So I have done. Now it is stationary. Okay, you can see the computed value is greater than the critical value. All the critical value, 1%, 5%, and 10%. So it is found to be stationary. Okay, so this is unit root test. So this you have to repeat for public expenditure also. Okay, so I will stop with this unit root test. Further we'll discuss in the next class. So can I close the session?
Yes, sir, we can, sir. It's
Okay,
getting
madam.
late already. Yeah.